So here's an exciting thing. Here is an exciting thing, class, is that sometimes the daughter nucleus is also radioactive. Sometimes the daughter nucleus is also radioactive. I don't know why it's always a daughter, right? So for example, uranium-238, and if you look at this table here, the way they've got it marked off, why do they have the mass number changing by 4? Because it's alpha decay, right? It can only change by 4. Mass number either never changes or it changes by 4, correct? Right? And then the atomic number can change, and these are changes that don't change the mass number, but they change the atomic number. So they must be what? They must be beta decays. And if it's a move to the right, that is an increase in atomic number, then it must be which beta? Beta minus, because you get more positive and more negative, and therefore there's zero charge change, right? So uranium-238 turns into thorium-234, which then apparently beta decays, a half-life of 24 days, 6.7 hours half-life, and it's back at uranium again, going, damn, I just was uranium, right? Okay. Then it decays, alpha decays, and this one has a half-life of 2.5 times 10 to the, I don't know what that is, probably 10 to the 6th or something years, or 5th, right? And it's thorium again, right? And then radium, then what is that, rhenon or something like that? Radon, right? Then it's polonium, is that what that is? Right? And then at this point, and this is crazy, the path, can I interrupt? Hello? Are you talking about physics? Okay, right? Then at this point, it's like a cross-country race where they've failed to mark the route, but it's in a city, so it doesn't really matter. People are going either way through the blocks, right? Okay, but it can go either way. It can go this way or this way. It can alpha or beta decay. The products of that can alpha or beta. The crazy thing is this: all arrows lead eventually to lead 206, right? Or at least you are lead there. And lead 206 is stable. It doesn't decay at all. And so it's game over. Isn't that funny? But of course, it's kind of a stupid thing to say that the decay series ends on a stable element, because where else would it end? If it's not stable, it doesn't end, right? So let me just show you something that is very cool. Okay? Let's go to that chart. I know. I just want to find it. That one's we've already navigated through the whole thing. Class, shut up. Can I have your attention, please? Okay, so I'm going to just find uranium, which I think is like in here somewhere. I would click here, but that's none of your business. Thank you. Okay, uranium-238 is where it all starts, right? And if you recall, uranium-238 alpha decays to thorium-234. Yeah? Yeah? Right? So let's go there. Ooh, it's just as quick as that. Look at that. Okay, that betas to palladium-234, which betas to uranium-234. So we've just done this, right? Alpha, beta, beta. Yeah? Now we're going to do a bunch of alphas, right? Alpha, another alpha, thorium, to radium, to radon. I was wrong about that, right?
Why is radon? That doesn't make sense.
No. These are the decay products. This is what it is, where we are, where we're going, right? This turns into lead 214. Yeah.
What determines if it's an alpha or beta decay? Was that like a crossroad?
Random, flips a coin, right? There's not only don't we know, but there's actually no hidden variable theory that will ever predict when it's going to decay and which way it's going to decay.
Could something have like a positive beta and then a negative beta and like just keep going back and forth?
Probably not, because it wouldn't be energetic both ways. Probably, right? I think it's a short answer, but I have to think about that more, right? But yeah, what we can do is with great accuracy predict the exact percent which go which way, right? And so if you look in this table, it'll show you the branch ratio, right? Almost all of them do this, right? Let's see if we can get down to one of those ones. And then 0.02% actually beta decay, so it's much more likely that they'll alpha, right? So we'll follow that one. This one apparently beta decays to this one. I'm going to click on that even though it's none of your business. Let's do the alpha. There we go. And we just keep clicking on this. Eventually we should end up or be led to lead 206. There are no things, right? These are the parent nuclei, so that's going back up the other way, right? But there's no daughters of this one. That's crazy, huh? Isn't that sad when you don't have any daughters? That's sad. Isn't that crazy? That's wild. Isn't that wild? So this is your homework tonight, is to go to that website, go home, go to the physics site, click on links, click on this one, right? And then just find all the radioactive guys are going to be up in here, right? So click on something that's radioactive, right? The gray ones are always a good bet, right? And then just start clicking on these and just see where it leads you. You can find your own decay series. There's lots of them out there, right? And it used to be that you had to do it by like leafing through this book that was honest to God like this thick, right? You know, and like this big, and cost like $200, and you had to leaf through it and you'd tear the pages because they were so thin, right? It's one of those reference books with the really, really thin pages. Now you just click on the link and you get the data. And this thing is generated on the fly by a script from just tables of the latest data, which is a very cool thing. And yeah. Smarter than Watson.
Watson's a dirty cheater. Yeah, Watson's.
Okay.